All right, 5.4, complex rational expressions. So complex rational expressions just means fractions within fractions, okay? Because a rational expression is fractions, right? We're doing our division within those pieces. And so to make it complex, we're going to put a fraction within that. So let's look at how we're going to handle those things and work through those problems, all right? Now, we don't have any definitions here, so we're going to go straight to our examples. And we're going to use simplify as our instructions here. So number one, let's just start with numbers. So 2 plus 3 over 5, all divided by 4 minus 1/2. Okay. Now, when we're dealing with these, we need to get this where it is a single fraction over a single fraction. That's going to be our first goal. Okay, so if we don't already have that, we need to do that. So let's do that here. All right, so we need to get a common denominator here with this 2, remembering that's 2 over 1. So we can use our calculators, whatever we need to get that piece for those, okay? All right, so 2 over 1 becomes 10 over 5. So 10 plus 3 is 13 over 5 for our top piece. And then again on the bottom, 4 over 1, that becomes 8 over 2. 8 minus 1 is 7 over 2. Okay, for those. Now that I have a fraction over a fraction, we need to remember what that means. That means a fraction divided by a fraction. So we can change that. We can use our keep the top, change to multiplication, and flip the bottom. Okay? So we just use that knowledge of what the math tells us. Now, we multiply straight across and reduce, or reduce and then multiply straight across. There is no reducing here, so 13 times 2 is 26. 5 times 7 is 35. And so since that does not reduce, that is our answer. But we do always look, can we reduce those pieces? Right? All right, now let's start putting some letters into this. Let's start real simple here. X over y squared, all divided by y to the third over x squared. Now, you will begin to notice that when they do these, there's going to be one fraction bar in the middle that's a little bit longer than the other fraction bars. With those, I exaggerate it a little bit more so that I don't make any mistakes with it. I know exactly where my middle division is for those pieces, and you may want to do the same. All right, well, I already have a fraction over a fraction, so I can go straight into change flip. We keep that top one. So x over y squared, change to multiplication, and flip that over. So x squared over y to the third. Well, there's nothing to reduce. X times x squared is x to the third. Y squared times y to the third is y to the fifth. Okay, but again, if we can reduce, we need to do so. Three. So 9x squared minus y squared over xy, all divided by 3x minus y over y. Okay. Now, even though it looks a lot uglier, there is still just a fraction over a fraction. So I'm going to start with getting rid of that piece. And so I get 9x squared minus y squared over xy times y over 3x minus y. Now, before I start reducing, we need to look at this as we did previously of simplifying, of trying to factor things, and then we can cancel on top and bottom for those. So I do see here that I can factor this 9x squared minus y into 3x plus y, 3x minus y, and then we have xy on the bottom times y over 3x minus y. I'm going to go ahead and put that in parentheses so that it matches other parts of my problem. All right, so now we want to eliminate. I see a 3x minus y on top and bottom. Also see a y by itself on top and bottom. And so that leaves me with 3x plus y over x. Don't forget about that x right there on those. There's nothing else. This does not reduce. And so that is my answer. Okay. Right. So 3 over x plus 4 over y, all divided by 4 over x minus 3 over y. All right, so again, here we can see that we have to get a common denominator first to be able to work through this. Okay. So up here, this one's going to need a y. This one's going to need an x. This one's going to need a y. And this one's going to need an x. So that we have common denominators. So up here on top, I have 3y plus 4x over xy. And then on bottom, I have 4y minus 3x over xy. So now we can keep change flip. So 3y minus 4x over xy times xy over 4y minus 3x. Hopefully we can see here the xy's are going to cancel. But we can't do anything, no factoring out of those other pieces. And so we get 3y minus plus 4x over 4y minus 3x. And that is our result there. Okay. All right, let's do one more. This was going to be the longest one that we have. So it's going to take us a bit to work through it. So if you need to, go ahead and pause the video if you need to finish writing that down so that you can. But I'm going to go ahead and erase it because I'm going to need this whole board. All right, number 5. 1 over x plus 2 plus 4 over x minus 3, all divided by 2 over x minus 3 minus 7 over x plus 2. All right, so we need to get common denominators. So I'm going to go ahead and put all of these pluses and minuses in parentheses so that I can see everything that I need to do and work with. All right, so this needs an x minus 3. This one needs an x plus 2. This one needs an x plus 2. This one needs an x minus 3. Okay? So I've got a lot of stuff going on there. So I'm going to rewrite it just to be real clean here. We have 1 times x minus 3 plus 4 times x plus 2 all over x plus 2 x minus 3. We're going to have our other piece on bottom, 2 times x plus 2 minus 7 times x minus 3. And again, we have x plus 2. Excuse me. Sorry about that. All right, so from here, there's a lot of different ways we can do things. We can do multiple steps at the same time if we would like to be able to work through those pieces, okay? I'm actually going to do that. I'm going to go ahead and distribute, and I'm going to keep change flip at the same time because I just don't want to work too hard here on these pieces, okay? And so that's what I'm going to do in this next step. So on the top here, I want to distribute, and it's going to stay here. So 1 times those give me x minus 3. And 4 times x is a 4x. 4 times 2 is 8. And then we're going to get x plus 2, x minus 3. Okay. I'm going to change this to multiplication. And I'm going to flip this bottom one over. So on top, we're going to get x plus 2, x minus 3. And we don't multiply those things out unless we have to do that, okay? So we're not there yet. All right, here I'm going to distribute in. So I'm going to get 2x plus 4. Distribute in here. So minus 7x minus or plus 21. All right. Now, the reason why I did that is we can see here, I've got pieces that are going to eliminate already, even before I do anything else. And I can combine this as one single fraction now. All right, so let's combine like terms on top and bottom and create one fraction. All right, so we have x plus 4x is 5x. Negative 3 plus 8 gives me a positive 5. And here on the bottom, 2x minus 7x is a negative 5x. 4 plus 21 is positive 25. All right, so now we want to factor out anything that we can. So in this case, we can factor out a 5 on the top, get x plus 1. On the bottom, we can factor out a negative 5 and get x minus 5. Well, our 5s do cancel, but we still have this negative. I'm going to move it to the front of my fraction, out in front, not on top, not on bottom. And then I have x plus 1 and x minus 5, and those do not factor. Okay. And so that's how you can look at those pieces, break them down, moving them forward. Okay. All right, we need to look at one more thing. It's kind of a different concept. It is a formula, but it does apply to rationals and using what we've done here and simplifying to make sense out of it. And those things are called the difference quotient. Okay, the difference quotient. And so this is going to be a formula, f x plus h minus f of x, all divided by h. And so we're going to apply that formula to some functions and see what happens. Okay, so let's do that here. So number one, we're going to find the difference quotient, and we're dealing with f of x equals 3x minus 5. Okay. All right, so we're going to plug in. So what I would suggest that we do here, we're going to have a couple of brackets. And those brackets are going to represent these two pieces. So my first bracket is going to be f of x plus h. My second bracket is going to be f of x. And then we're going to divide all of it by h. Well, let's go ahead and fill in the f of x. That's the easy one. It's already given. So that one just goes in here, 3x minus 5. Now the other one, instead of an x, we need to do 3 times x plus h, and then minus 5. Right? So that's going to allow us to fall within the formula as it's presented. So now we're going to distribute. So we get 3x plus 3h minus 5, and then distribute this negative as well. Minus 3x plus 5, all divided by h. Now, if we've done our math correctly, anything that does not have an h on it is going to kill each other. So we see here a 3x and a minus 3x, negative 5 and positive 5. And so I'm left now with 3h over h. Well, we can reduce that. The h's then cancel out, and my answer is 3. Okay? And so that's always going to happen. So let's try again there. F of x equals x squared plus 1. Make sure I wrote that down correctly. Yeah. All right, so we're going to do the same process here on this one. We're going to break it up distribute, do the things that we need to do. Okay. All right. So here we've got first piece, second piece, and then all divided by h. We know that x squared plus 1 goes over there. And then x plus h squared plus 1. Make sure we put that in parentheses so that we square it out. Now, if you need to, go to the side over here. This is my scratch word. X plus h times x plus h. That is what x squared or x plus h squared means. Okay, so this scratch word is for x plus h squared. All right, so we work that out. We get x squared, xh, and h squared. So x squared plus 2xh plus h squared. So that here, all of this is going to go right over here in place of that. Okay. All right, so x squared plus 2xh plus h squared. We still have the plus 1. And then we need to distribute minus x squared minus 1 all over h. Our x squareds cancel, our 1's cancel, and that leaves me with 2xh plus h squared over h. Now everything has an h in it. So that means on the top of that, I can factor out an h and get 2x plus h over h. So those eliminate, and I'm left with 2x plus h as my final answer. Okay? And so that's how we're going to work through those and do this. We can get letters as part of our answer. We can get a whole number as our answer. It's all based on the equation. All right? Now, the crazy thing that we just did calculus 1. We took what we call the definition of a derivative, and we were able to find those answers, okay, using what we know here in college algebra. So that's why we need to know these things, so that if we move on to higher math classes, we will be able to use that information and apply it to whatever we're doing. Okay?